Good afternoon, all. Welcome back to 115. Another wonderful day. Hopefully, you all are doing well. What we're going to be talking about today is sort of tying together all of the crypto uses. And to do that, what we're going to do is this is going to demonstrate how we can use this library, the libraries, to create a login system for our music rating app. So I'm going to give people a couple minutes to connect, see how things are going, make sure everything's going okay. So in order to do this, before we get there, one thing I want to point out, just for benefit potentially later on as you're doing other things, if you look here, you can see that I have my files pretty strongly structured. One thing that happens is at the end, when I show, all of the different functionality we have here, there's a lot of different things going on. There's a lot of files, a lot of functionality. And this can get very confusing. This can get very difficult. And this is part of why it's important to keep things organized. Part of what we've been doing with the Music Rater app, part of what we've been doing actually with the project, which I suspect a number of people are still trying to finish up right now, is to really try to structure the work so that you do it in little bits and pieces. And when you have to tie things together, it's not writing everything. It's not solving the whole world. The way that the project was developed, parts 1, 2, 3, and now 4, it really was with the goal, this step 4 in mind. And so the functions that you were writing all along were the ones that you would eventually need to use. We're doing the same thing here. And one way that you can make this easier is by breaking out where the files are. So you can see I've got a number of different files here at the top level. I've got my Python files, main.py. That's where all of the code for the web server for Bottle is going to be. Authentication.py. So we're going to add a new table to our database, the users table. And that table, what we're going to do is we will have all of the usernames. And I say, and if you look, I create the table and I say it's a username and a password. But in fact, we're not actually storing their actual password. Instead, what we're going to store is the result of taking that password, adding the salt, and then hashing the whole thing. Print DB table is just as I say, it's just something that reads in a table and prints out the results just for debugging and for demonstration purposes here. And finally, the ratings.py. This is the old ratings.py. The only difference now is that every song and rating will have a username so we can see if we want. And actually for the ratings, we will display who submitted it. So that way we can make sure that people only get to submit one review per song. They can't either, vote up or vote down their songs, everything else. We're actually going to be using two different sets of public-private key pairings. We have the public.pem and private.pem. This is just like before. We're going to be using this for making sure that we have encrypted data being sent from the client to the server. In this case, we're not going to be encrypting individual messages, but we need the user to log in. They need to type in their username and password. And the one thing that we absolutely don't want to do is send that password in plain text. We want to make sure it's ciphertext, encrypted text that we send over. So the way that we're going to do that is by using a public key, private key system. We're also going to have a separate set of keys in order to keep track of the users. One real weakness in the web with HTTP, HTTPS, is that it is, as we've talked about in the videos, it's stateless. That is to say, each time you request a file or any sort of thing, a file, you send an AJAX GET request, an AJAX POST request, any sort of connection, that's considered to be the entirety of the interaction. And if you then request a second page or some update, that is a brand new interaction. The server has no way of knowing that this is continuing. And while this is actually really, really fast, and it was great when they were initially developing it, this obviously makes things like, say, Replit, where I want to be able to change pages here, very, very difficult. I want to be logged in here, very difficult. So the way that we solve this is using authentication and using these cookies. So cookies are a little bit, I'll show it to you in a little bit how these cookies work. There's stuff that the browser keeps track of and sends with every request. And so we're going to need to keep track of that also. And then finally here on the front end, you can see that we're going to have two different web pages. The first page is our index.html page. But now, unlike before, what this is going to be is a page where we can just either create an account or log into an account. The second page we're going to have, this app.html. This is our standard page that we've been using all along, where we have the songs and we can search for an artist and we have the ratings and that sort of stuff. Then again, I've broken up my JavaScript files by functionality. So I've got the ajax.js, which just has my Ajax functions. I've got HTML helpers.js, and this is just the code to generate the various HTML code that we're going to be doing for the ratings and for the songs. Security.js is going to be somewhat similar. What this is going to do is allow us to register and log in. So it's going to handle the login and the registration process, and I'll talk about that in a little bit. Also getting a key, encrypting messages, getting a username, if we wanted to do that. And then app.js, which again is the old process of searching for a song, displaying the song, adding a new song, that sort of thing. This is basically unchanged. The only difference is we have this other function, welcome, which when we start up is just going to say welcome and whatever somebody's username is. So to show you how this works, let's just start actually running it. And it's going to take a little bit because at the very beginning, now I still have code there to not only create one set of keys, one pair of keys, but actually two different pairs of keys. So it took us a little bit longer to start up. You can see I've started this up with three different usernames, mhertz, which is mine. And you can see that what this is the salted and hashed password. For any of you who want to hack into this account, you may feel free. The password I actually used was password. And then I actually created two different users. I named them after my wife and daughter because it was the first names that occurred to me. So Sarah, which is my wife, has her account and this, again, hashed and salted password. The actual password was 12345. Again, if you want to hack into her account on the system, feel free. And then Shosh, my daughter's name, I also created a thing for her. And the interesting thing is that the password I used for Shosh was also 12345. But as you can see by these results, they have this first little bit that's in the common, that's the same everywhere. And that's just how the system is, what the system is using to identify what's going on there. After that, the actual hashed bit, you can see that even though Sarah and Shosh have the same passwords, once we add that salt to it and then hash it, we get very different results. And that's really important. This means that if anybody were trying to break into the system, and did not happen to know how I am what those passwords were, they didn't actually type them in earlier, they wouldn't be able to get back to the original passwords. They wouldn't be able to figure it out. And even if they broke one of them, they wouldn't be able to figure out the other one. So it makes it more secure. So suppose that we want to log in. I'll log in now. What I'm going to do is type in my username, type in my password. Well, first I'm actually going to create a dummy, try logging in as somebody else. So suppose that Cookie Monster wanted to log in. So username Cookie. We'll just do Cookie Monster. Password will be Cookie because, you know, C is for Cookie. So now if I try to log in, it's actually going to give me an error message. And what I want to warn you about is this is a great error message for a 115 demo for the class to show how this works. This is actually a horrible error message for a real system, right? The error message is up here. Username Cookie Monster not registered. If you're developing a real system, you don't want to give an error message like this because this would tell somebody, okay, let me try the next username and try to hack that out. And it would make it easier for a hacker. Normally what you'd want to do instead is just simply print out that, you know, it wasn't accepted or something like that. So to see what happens when we try to log in, let me go to security.js, right? When we try to log in, we will end up executing this login function. And so you can see it's going to get the username, get the password element, get those values, create an object with keys username and password, and that username and password as the values, turn that into a JSON blob, and to make sure that nobody can spy on us as we go across, as we send this across the web, and I'm going to actually output this. Copy and paste this in. Right, we're going to encrypt it. We're going to take that key, and the encryption function here is exactly as before. We're going to use that RSA algorithm with the OAEP protocol, use that to encrypt it with the public key that we got from the server, call B2A to turn it into ASCII so we can send it over properly, and then return it. So that process hasn't really changed, and then we'll just post it to login. And when we're done, we'll call this display login function. And what the display login function will do is it will check it'll get the JSON value, turn it back into usable JavaScript data. It will then use that object it gets in response and check out its authenticated key. If that key is true, it's going to use this little bit of a command, and this is part of the DOM process, again, that document object model, same idea. It's going to call window.location, that is the location up here, and .replace /app. So to show you how this is going to work, I'm actually going to open this in a new tab. Open up my web developer tools. And we're actually going to need to look at storage. You can see I was logged in here before. So now if I log in, and I click login, it's going to redirect me to that page. And you can see it asks if I want to save my login. Now note at the top here of this page, it says welcome M Hertz, in addition to having all of the other data there. So the way it gets this other data, so if we go to app.js, right at the beginning, what it's going to do is it's going to call this function getUsername that I wrote. And that's how it creates that welcome. And so what getUsername does is it's going to look for the cookies that we have from this web page. So if you look, you actually have lots of cookies on your browser, but a web page can only access the cookies from that site. So in this case, I'm only going to be able to access the cookies from this Replit site. So the trick is that those cookies come out as they're all key value pairs, but they all come out together. So I have to use this split thing here. So I get each set of cookies one by one. And what I'm going to do is split each key value pair, get the key, get the value. If the key is username, I'll return that value as the username. And so you can see when we logged in, and I'll show you how to do this. This was actually done on the Python side. It set 2 cookies on the system. And this is how we're able to stay logged in. We're not actually truly logged in. Instead, what happens is every time we make a request, we're going to be providing to the server this username and this token. The username is my actual username. It's what we can use to see that I'm logged in. And this token is hopefully, and it certainly looks like this, some random, just sort of mess of stuff that's a very specific token that will be used by the server to make sure we are who we say we are, right? Because one important thing to think about whenever we're using these cookies is note that they just live on the client's computer. They just live here. If I wanted, I can rename my username to Sarah and nobody would be the wiser. I'm able to change this at a moment's notice, though, in fact, it actually won't work. So just to show you, it's M Hertz. If I keep my username the correct one, so M Hertz, and I decide to do a review, it's an interesting cover. We'll give it a 4. You can see it's having a problem. Why is it having a problem? Because I changed something and I did not get it correct everywhere. If valid user. Because I have valid user and it's actually identity matches. So let me go change that. Sorry about this. So we'll restart. Actually, a good place to show you that one issue that will happen is because I'm generating the keys new each time, and we actually use that second set of keys to help figure out who's there. Even if I logged in before, waiting for it to start up. If I come back here and I'm still logged in and I try to do a review, note my review still doesn't go through, though now it doesn't go through because of this invalid decryption. In order for this to work, what I'm going to have to do is actually re-log in. And so when I re-log in, actually I'll log in as Sarah this time. You can see it updates, it still wants to do that. It updates that username and token. And now if Sarah wants to review this, she can, it'll be accepted. Should be accepted. Why is it not being accepted? Username is not defined. What? I didn't even change this code. So for those of you who didn't notice, there was a problem earlier today. So they're currently having problems on Replit. Note it says main.py line 96, which would be this line right here. Or no, main.py, excuse me, main.py. Need to get the username. So I tried to improve the code between the noon and now, and you can see that I made some mistakes because of course I did. Restart this up. So just to show you how the login process works, because we need to do that. Actually, it's going to work here. So let's just do this so we can see. Log in again. PASSWORD. So if I want to review this, now it'll work. Note that if I want to review it again to stack it up, because I'm logged in, it can see what's going on. I think I have it. It's just going to reject it. It's not going to allow it to go through. Note that if I try to do something else, so let's log back out real quick, log in one more time. So log in as Sarah. So she can do a review. Like that. If Sarah tries to change who she is by just changing this username, it's actually going to reject it. It's not going to let her do it. So we can actually have some security. So to see how this works, you need to understand how it works on the server side. So when a user registers, what we're going to do is get that JSON blob. It will be encrypted, so we have to decrypt it. Again, this is just like last time. The result will be that JSON blob, we get that. And then we're going to call authentication add user. And what this is simply going to do is check to make sure that the name is valid. So we have a real username and password. We won't let blanks in for either one of them. We then will call HTML escape username. And the reason we're doing this is since we display the username in the page, we want to make sure that there's not an HTML attack, an HTML injection attack. This actually happened to a student. So there's a tool. Some of you might know Alan Hunt. He teaches he's one of the instructors for 199, among other courses. So he and I also teach a course 404, CSE 404. And for that, we have this tool that we can use to track students around in that course. One of the students actually changed their name and included an HTML injection attack. Now, the master's students who had created the system put in place a lot of protections for most things. The one thing they did not include a protection for was people's usernames. And the reason they hadn't included that protection was because the only place a username showed up was when that person actually logged in. It had a little message. But what it meant is whenever that student tried to log in, he actually put an HTML injection attack against only himself. Not really good. But just to make sure of it, what we're going to do is we're going to call HTML escape, make sure that it's safe from HTML injections, and if it's not the same, if they have some characters where it might be an HTML injection, we're just going to refuse that username. Rather than trying to recode it or anything else, I'm just rejecting it. It's easier that way. Then we'll say if username already exists. And how do we check if the username already exists? Well, we just do a selection from the user table for that username, right? If there's already a row in the users table with that username, then the username exists. That's pretty much the definition of it. So if it already exists, we'll reject it. Otherwise, what we're going to do is take their password, and we're going to use this bcrypt library. It's got a function hash pw, hash password. And what we're going to do is we have to pass in an encoded version, that is the byte sort of version of this string. So it takes the string and just turns it into bytes that the computer is more comfortable using. And we have to pass in salt. So we just call bcrypt.gensalt. It has a function to do that. And with that, we get the hashed result. And so what we're going to add into our database is not And where you see these two things at the top here, for Sarah and Shoshana being so similar, it's not that their passwords are that different. Their passwords are identical, but the salt for their passwords is different. And so when it gets hashed, the results are different. And so it's that hashed result that we add in, and that works well. So when someone wants to log in, what we're going to do is go back to main. Right? We're going to get that encrypted blob. We'll decrypt it, turn that JSON blob that was the result of the decryption into usable JavaScript data. We then will call login attempt. And what that's going to do is when we do a login attempt, we check if there is no username. And again, this isn't a good idea normally, but we're going to do it now. We'll send back that error message. The person isn't registered. Otherwise, we call authenticate, and that just simply says, does another selection like before. It's going to say select the row that has that username. But now we can't compare the password because we know the passwords aren't going to be the same. Instead, what we're going to do is we'll take that password and encode it, and we'll use that bcrypt library to compare it with that result. So the bcrypt library can add its salt, do that hashing, and make sure that the result is still identical to what's in that table. If they are the same, we return true, and we say that the user's logged in. Otherwise, we'll have a message, incorrect password. So back into main, if we were able to authenticate, if that username and password matched, then we're going to set two cookies. The way that we set a cookie is in the Python side, we say bottle.response.setCookie. So it tells the browser, set a cookie for this site. And cookies, like I said, are key value pairs. So the key will be username for one of them, and the value will be whatever their current username is. The other thing that we're going to do is we're going to create that magic token. And the way that we're going to create that magic token is we're just going to use a second set of keys and actually encrypt their username. So we're going to take that username and encrypt it, and we're going to set that as the value for the token cookie. So what this means is what we have here in these cookies here are two different things. We've got the username and then this token, which is actually just an encrypted form of this username. And the thing about this is the only way to know that is to know the Python code, which we don't share with users. So they're never going to be able to look at that to know that that's the case, to try to hack it out. So what this means though is when I changed the username here, when I pretended, when Sarah tried to be me to submit it, so we can look at rate song, what we can do is check to make sure that that token is valid. So I'm going to call this if identity matches. And what identity matches does is it first gets that verified username. It gets the value for the token while we're connected. Both the username and token are sent over. So we'll get the value of that token cookie. If the token cookie doesn't exist, then we know that they're not a verified user. Otherwise, we decrypt it. We'll get the value of the username, and we'll make sure that the two match. And if the two match, then we know it's correct. So when the username here is Sarah, which matches that token, then the two things will match, and we'll use that as a username. On the other hand, if they don't match, then we know somebody's trying to hack the system, and we're going to reject it. So when that happens, we'll return none, and that authentication of whether this is actually a real username in the system will fail. So the only way this identity matches will succeed is if they have both a username that's valid in the system and they have the right token for it. They have the right encryption for it. And so this will really prevent people from being able to hack into our system, from being able to pretend that there's someone else, from not logging in. And so the way that, add rating is going to work, if the identity matches, we'll then get their username so we know that that's the correct. And then the rest of it actually is the same as before. We get the JSON blob, turn that JSON blob into usable Python data, call the rate song function, and then respond with that full set of ratings. For add song, we're going to do the same sort of idea. If you want to get the full list of songs, we're going to let anybody do that. You don't have to be logged in for that. But using all this whole process, we can make sure that people are who they say they are and actually track their ratings as they go. So that's sort of a quick way, a quick sort of view of how we can use authentication. What we can do is we're going to have to use cookies. Those cookies are going to store some sort of private information that we use to track who they are. And typically we're going to not only have a username, that'd be easy to fake, but some magic token. Here I called it token, their encrypted name, some sort of important piece of data that we can use to follow them around. So that's kind of a quick overview of how this works. Again, the idea is not that you're necessarily going to go out and write full authentication systems. Please don't. This isn't necessarily the most secure, but it's good for 115. But we want you to understand, I want you to understand the big picture of how all of this works. If that makes sense to all of you, that's great. If not, please ask any questions. I don't know if you have any. This would be a good time to ask them. Okay, I don't see any questions. I'm trying to handle the pause there. I know there's a little bit of a lag between when I say something and when it goes out. So thank you all for paying attention. I hope you have a great weekend, that you stay safe, stay healthy, and make sure you have a little bit of fun. Just to let you all know, just to remind you, before Monday, the plan is for me to have in UB Learns a sample set of questions, kind of like a sample set of questions for the final. The actual questions on the final will be different. The idea of these sample questions is just to give you an idea of the range of topics that I could ask about when we come up with get to the final exam, and also for you to get a feel of what the different types of questions are. I know at one point I did set a goal to have it actually out by today, but what I've been doing over the last couple of days especially is really trying to prioritize helping everybody with a project. Let's push back the time for that sample final to be there. It will be there before Monday. So with that, thank you all very much. Like I said, have a good weekend, stay safe and healthy, have a little bit of fun, and I will talk to you Monday. Bye.